All right, so welcome back. I'm going to be talking about section 6.2 in this video, and it's continuing the algebra theme, working with variables. 6.2, we talk about various formulas that come up throughout our book. So it says a formula is an equation that typically has a real-life application. We will use a variety of formulas. These formulas actually, as seen throughout this course, compiled in this section. You will be given all but one of the variable values, and then you're able to solve. You know, if they don't tell you what some of these values are, for example, simple interest, the formula is I equals PRT. So I can't really solve that if I don't know what some of the variables are, but if they tell me some of the values, I can solve for one unknown in it anyway. But you have to have some information, otherwise it's just a formula for us to be aware of. So this first formula, interest or simple interest, it's affected by three things. The principal, which is how much money you invest. Say it's a savings account, so it'd be the principal, how much money you put in the account. The rate of interest, you know, if you get 5% or 2% or 0.5% at the bank, you know, that's going to affect how much interest it grows. And then the time, how long you leave it there. The longer you leave it there, the bigger your simple interest will get. So actually all these are considered direct variation variables because each one of these, the more you got of any one of these, the higher this is going to be. It actually just multiplies it. All right, so those are the three factors that affect simple interest. So our example is determine I, so we don't know I. That's always easier if you don't know the one that's isolated. And it gives us P is $100. R is 6%. Notice it gives that in a percent as a rate. We are responsible for getting rid of the percent sign by going to left always before we insert it into our formula. So 6% needs to be changed. And then time, it says is 3, which is going to be 3 years. So these two have to correspond. Typically, it's assumed that it's an annual interest rate, so it's based on years. And then that means time needs to also be in years. So these two need to correspond. And again, the fallback, the default is this is in years, so this is in years. All right, then we hit our calculator, multiply those three things together, and the simple interest is you would gain $18. If you had $100, you threw it in the bank, at 6% interest, you left it there for 3 years, they're going to give you your $100 back and your $118 extra. You're going to have $118 compiled. All right, the next formula, compound interest. Okay, and here's the formula for that. A equals P, 1 plus R over N, raised to the NT. So compound interest takes your money and it compounds it or adds your interest in incrementally. So maybe they send you a statement from your bank like quarterly. So that means like 4 times a year they're going to send you your statement and they're going to roll your interest in. And so say you're up to $118. Now they're going to reconfigure your interest for the next quarter based on $118 instead of just on the 100. So it compounds that interest, adds it in incrementally. On this formula does it so you don't have to do it repeatedly, especially if it's for a lot of years. That would be hard to do. So the formula does that for us. It takes your principal, how much you invested. The one says it keeps adding in the original amount plus the interest, the rate of interest. N is how many times it's compounded. Like if it's quarterly, that'd be 4 times a year they roll it over. If it's semi-annually, you'd put a 2 and so on. And then T is how many years, the time. So this will be studied further in another chapter. For now, they don't really tell you what all those stand for. They say just work this out. And it says determine A when. So that's good if you don't know the one that's isolated. That's helpful. We'll be changing it up some later. But let's take our $100 at 6%. So that's R is 0.06. N is 1. So we use N in the exponent as well. And T is 3. Now, when you do this on your calculator, and you will want to do it on your calculator, you do need to be careful how you type it in. Because like we talked about on the last section, order of operation is important, so you need to tell your calculator exactly how this is supposed to be. The one mistake I get the most probably emails about is this one right here. If you type it in directly like, and most of the time my students get this right, they say 100. Some calculators require you to put the time sign there and some do not, so that you have to check yours. Then you do 1 plus 0.06 divided by 1, close your parenthesis. Then we know that means up arrow to do the exponent. Now, right here's where it's important. If you do not put a parenthesis around this 1 times 3, it needs a parenthesis. But if you didn't, you just typed it in kind of how it looks there, which you don't even think about this needing a parenthesis, but it does. The reason is your calculator would do parentheses first. It would take it to the first power only. It would not know that you wanted it to be the 1 times 3 power. It can't see that. It just sees the way you typed it in. So it'd only take it to the first power, then it'd multiply by 100 and multiply by 3. So it's very important you tell your calculator this needs to be parentheses as well, or just go ahead and know that's just 3. 1 times 3, you could kind of just do that in your head. So anyway, type that in. The answer key says it should be $119.10. So notice that compound interest is a little better than, oh, I already said the simple interest. It always is. When they compound it, they roll your interest into the principal more often. You're always going to get a little more money there. And the longer the time, the better compound interest helps you out. All right, next formula. We have a statistics formula. The z-score formula, and again, we're going to use this the last chapter as statistics calculation. They use a lot of Greek letters in statistics, so you'll notice this. They left our regular alphabet and went Greek on us. So we'll say this as let's see, this should have been x bar. I probably couldn't figure out how to put the bar over it when I typed this, but x bar minus mu over sigma. And then it gives you the values. It says find z when. So we're filling in our values again. And again, it tells us to solve for z, plug in x bar is 66, mu is 60, and it's over sigma 15. So we plug that, again, use your calculator. If you do this on your calculator, you need to tell your calculator what's in the numerator and what's in the denominator, or just do it by hand. 66 minus 60 is 6. 6 over 15, you could work that out and get 0.4. Here's the mistake I see sometimes online. If you type it in your calculator, 66 minus 60 divided by 15, just sort of like what you see, your calculator doesn't know that you were supposed to do this first, the numerator first. It would use order of operation, do the divide, and then subtract that from 66, which would not be right. So you need to tell your calculator if there's a numerator operation or a denominator operation to do that first. Do these like separate problems and then do the divide last. That's how we assess fraction problems. So you do need to have a parenthesis around that numerator if you're strictly typing it on your calculator. Then it knows it's 6 divided by 15. That needs to be done first, like I said, because calculators know order of operation, so you have to be careful around that. All right, let's see, what else have I got? Oh, slope-intercept formula. Y equals mx plus b. That comes up in pretty soon, later in this chapter. That's our graphing lesson. So y equals mx plus b represents a line y equals slope is always in front of the x variable plus b, the y-intercept. So we're going to be using that in a little bit. So here's what we need to learn in this section about this formula. So to help us graph our lines, whenever our line is in general standard form, x plus the y equals a constant, that's a standard form for a line. If we can rearrange it for the y variable and have y equals, it will be easier to graph. So in this case, to solve for y, to get y alone is what it's saying, we throw this 2x across the line. So we know when we move a term across the equal sign, it does the opposite sign. So y is still there. And it's a positive y, or just y. The 2 becomes minus 2x, and then the 10 was already there. And so that's all we had to do on that one to get it solved for y. Okay. And then that's going to, like I said, that's going to be good for our graphing section. That's going to tell us the slope of our line and where the y-intercept is. We'll use those 2 keys to graph it. Okay, there's more, and then we'll get to practice eventually. Let me get through some more formulas that we see. Geometry. In the geometry section, we have a formula for the volume of a box. The volume of a 3-sided figure, a rectangular solid, is the length times the width times the height. You multiply the 3 dimensions. Length times width times height for any box. situation. So how much will fit in it, the volume that goes in the box, will be V equals LWH, those three times together. So for example, find V when you know the length is 5 centimeters, the width is 9 centimeters, and the height is 3 centimeters. It's good they're all in the same units, and that's important when we get to this section. They do need to be in the same unit, so when we multiply, it'll be centimeters times centimeters times centimeters, which is the measure cubic centimeters, which is a measure of volume. Then we do our 5 times 9, which is 45, then times 3. Let's see, 12, 13. That's 135 in cubic centimeters, cc's. All right, one more formula, and then you can pause and practice. I'm having trouble erasing that. It's staying on there pretty thick. Okay, the last one, Fahrenheit to Celsius. So we're going to convert between Fahrenheit and Celsius when we do our metric section. So one thing they could do is just say, which would be nicer, easier problem, just tell me what Celsius is, and I could plug in 100 degrees Celsius. Let's do that. I didn't put it on your paper, but we have time on this video to get that in. Let's do some where they tell us some of the Celsius values and we get to use our formula. Let's say Celsius is 100. What's 100 degrees Celsius in Fahrenheit? So when Celsius equals 100, plug that in for C. Fahrenheit will be 9/5 times 100, or 100 over 1, plus 32. Again, you purely do that on your calculator. By hand, I picked a number that would go evenly 20 times. So that makes 180 plus 32, which is 212, I think, right? Yeah, 212, which is good to know because that is our boiling point. And in Celsius, it's 100 degrees. In Fahrenheit, when we switch it to Fahrenheit, that's our boiling degrees. They call Celsius the centigrade scale because it's based on 100. 0 is freezing and 100 is boiling. In our Fahrenheit scale, which we're more accustomed to though, we know 32, an odd number there, 32 is freezing, and then this is the boiling point, 212. So just to note, that converts it out. But what I've asked you to do here, kind of a harder question, is rearrange the equation so you can solve for repeated problems if we did it the other way. Solve it for Celsius. So get Celsius formula here, get Celsius on one side. So if we want this isolated, we throw the 32 across the line, makes it F minus 32. Okay, and then to solve for the C, we could times by 5, a trick we learned a little bit earlier, and clear the fraction. But what we typically do, the way we see this formula, is they times it by its reciprocal, 5 ninths. If you times this side by 5 ninths, it wipes all that out and leaves C, solve for, which is the goal. Then you have to do this side, you have to do the same thing, times 5 ninths, so we times this side by 5 ninths. So the Celsius formula converted over Celsius, and I know I've got it written backwards, but Celsius equals 5 ninths F minus 32. So these are equivalent formulas, but that's just manipulating the algebra, rearranging our variables to have equivalent equations, but just handier. If you're going to do a bunch of Fahrenheit calculations, you want to plug in Fahrenheit, you can plug that in for F, and you'll be able to punch it on our calculator. If you're going to do a bunch of Celsius conversions, this formula is more handy because you can plug directly in for C, and then again, it's a punch on our calculator. But they're both, you could use either one for either, as it turns out, but just handier that way. All right, so please do the activities and then come back into the next video.